Today we are going to discuss about industrial automation. Actually, automation is nothing but it's a Greek word. Here, auto is nothing but self, and machine is nothing but controlling. And that means self-controlling. Industry should control in automatic way. That is the main agenda of the industrial automation technology. In industry means there are so many industries are available, like oil and gas industry, other paper industry, glass industry, rubber industry, cement industry. Okay, there are so many industries will be there. Okay, to control the industries in automatic way, we are going to use this technology. Okay, in that first point is PLC, programmable logic controller. Okay, before going to discuss about this one, every industry is having different machines is there, right? Every machine we are going to call it as a application. It is a cutting machine or bending machine, filling machine, capping machines, label machines, otherwise pick and place. Okay, otherwise packing machines. There are so many will be there, that all comes under the application. Every application is having different SOPs. Every machine is running in certain set of procedures, certain set of operations. That operations we are going to call it as a SOPs. SOP is nothing but standard operating procedure. Okay, every machine is running in a step-by-step procedure. Some people are they are going to maintain this SOP like algorithm types. Otherwise, they are going to maintain a PDF. Otherwise, they are going to maintain like backup of the programming, everything. Okay, but I will take some small examples so that I will interlink with the PLCs. Let's say, for example, I am going to use one conveyor system, conveyor bottle filling system. To control, this is a conveyor. To control this conveyor, we are going to use one motor. To run this motor, I am going to use one on button and one more off button. When I press this on button, this motor will run. When motor is running through gearbox, this conveyor will run. Okay, whatever the bottles is there on the conveyor, conveyors will move. When it reach to my set point, how can I know whether it is reached or not? I am going to use one sensor here. Sensor will detect the object. Next, after that, whatever the tank is there, tank valve is there. Valve will open and it is going to fill the tanks. Once this bottle has filled, then automatically valve will go into off. Then motor will run again. Then one more bottle will come. Next again valve will open. Like that, automatic production is going on, right? This is we are going to write in a step-by-step procedure. Let's say, for example, first point is we are going to turn on one on button. Through this one, motor is running. Next step is sensor is detecting the object. Sensor on. Next, when sensor is on, motor should stop, right? When conveyor is going to stop, then only you can do any procedure like filling or capping or labeling, any kind of. Okay, once motor is running, next valve is running. After 5 seconds, same valve is going to off. Next again motor will run. Motor is running, conveyor will run. When conveyor is running, next sensor, next motor stop, next valve. Automatically there is a step-by-step procedure will be there. This step-by-step procedure we are going to call it as an SOP, standard operating procedure. Okay, let's say, okay, SOP is there, industry is there. What PLC is going to doing here? PLC is an hardware device. To control or to write a program, we are going to use one software. Okay, every software we need to install in our personal computer. Every PLC is having different softwares. Okay, that we need to install in our laptop or desktop kind of. Okay, after that we need to start the program. To satisfy this SOP is our major agenda, right? To control this one, to do this SOPs, we are going to use one PLC system. Okay, let's say, for example, I have written a program according to this set of procedures and I am going to dump into our PLC, right? Next, once on button is running, right? On button wiring, we should give it to the PLC. Once on button is running, then it will scan the program. Then our motor will run. Once motor is running, sensor will detect the object, right? sensor wiring we should give to the PLC. Once sensor is running, motor will stop. Next, valve is running. After 5 seconds, valve will off. Then motor will run again. Then conveyor will move. Then automatically sensor will detect. These are all continuous procedure, right? These are all we are going to call it as an input to the PLCs. And these are all output to the PLCs, right? These inputs are output device where it is. It has located in the application itself only. Application is but this one only. The system is there, right? This one. Some people say it is going to call a machine or a application or a field like that or a process. What PLC is doing that, but it is taking inputs from the field, scan the program, controlling the outputs. This is what PLC is going to doing here. Okay. Next, go with the HMI. Second. One second. Next topic is HMI. HMI we are going to call it as a human machine interface. Otherwise man machine interface. Okay. In the name itself it is having the name as human machine interface. Before going to that I will show the PLC also. This is the PLC. Okay. This is the inputs. These are all the outputs. Whatever the push button sensors will be there, all we need to connect here. It is scanning the program, generating the outputs. Okay. Every PLC is having their own softwares that we need to install in our PC, and we need to write a program of this SOP related. Okay. Let's go with the HMI. In the name itself, we have human machine is interface. That means interlink between, otherwise interface between human and then machine. Interface is nothing but not only one direction, right? Both direction it should run, right? Let's say for example, HMI is also having same thing, hardware touchscreen device. Touchscreen device. Right? Let's say for example, if that machine is having one motor here, otherwise two motors. Okay, I need to run these motors while touch the screen. Okay, let's say customer or client is asking, there is one on button, there is one off button, there is an on indication, off indications. Okay, this is just a screen itself only. Every HMI is having their own softwares again. We need to install in our personal computer and start the screen design. Okay, I have designed the same screen. I dump into this device, HMI device. As a machine operator is there available, right? They are going to maintain this HMI related topics or it. Okay, let's say for example, once on button is pressing. When I press this on button, first signal will comes to the PLC. Okay, PLC can decide to run these motors. As a programmer, we need to interlink with the HMI also. Okay, whether motor is running or not, that feedback will come to the PLC. Then again, that signal will come to the HMI itself. You are going to controlling here, right? You are going to operating or controlling, right? It is going to call controlling. Whatever the feedback is there in the machine, that you are going to checking or seeing it here, right? That is we are going to call it as a monitor. Monitor and controlling. Monitoring and controlling of single machine. Let's say for example, if I have 10 machines is nothing but it won't work out. If you have only say a single machine, it is going to work out over there, and then we can run the machine monitoring and controlling. Okay, every signal will again come to the PLC. Okay, what we can monitor here? We can monitor the feedback of the motor, whether motor is on mode or off mode, whether motor is in forward direction or reverse direction, otherwise motor speed. Okay, let's say for example, if you have any tanks is available, what is the tank level, what is the flow rate, pipe flow rate, what is the pressure is running inside, temperature is running inside, everything you can monitor here. Okay, we have many parameters that we can discuss in the course itself. What we can control it is. Okay, what we can control is that we can control the speed of the motor, we can control the temperature, we can control the level, flow, pressure. Okay, and then we can control the countings also, otherwise bottle sheet lengths, etc. Motor on off, forward reverse, fixed speeds, everything we can control through this HMI. Monitoring controlling of a single machine is going to call an HMI. Okay, that is also in this HMI also we are going to learn about Delta, and then Siemens is available. Okay, next. Let's say for example, if I have total plant, there is for example purpose I am going to take one steel plant. Okay, every plant is having their own different sections, right? Section 1, section 2. In section 1 I have one cutting machine 1. Here I have cutting machine 2. It is having their own related SOP, right? It is also having their own SOP. To monitor and controlling, here I am going to use one HMI. Here also same one more HMI. If you have multiple SOPs, multiple machines also, a single PLC can control. A single PLC can control entire plant designing control system. Okay. Let's say here production is running, right? This production is production area. We are going to call it as an production area or as work area. Okay. Or I'm going to treat it as a local area. Every plant is having a controlling system, right? In a control room. In this control room, they are going to see entire plant system in a single personal computer. Let's say section 1, what monitoring we need to control it. Section what's going on, cutting machines is running, okay. How many cutting sheets is going to running. Okay, everything he can monitoring here. Section 1, what is going on. Section 2, what it is going on. Everything he can monitor. And everything he can control also. Okay, this room we are going to call it a control room or power room. I am going to treat it as a remote area. That is local area, right? It is a remote station. From remote area, we are going to control the monitoring and controlling of entire plant system. And every signal will come to same PLC itself. Okay? If you want monitoring, let's say you hear monitoring, it is going to call a monitoring. It is going to call a controlling. Right? Let's say for example, this personal computer is completely a software device. Okay? This software device we are going to call it as an SCADA. Third topic is SCADA. SCADA is nothing but supervisory. It is supervising the total plant and it is going to controlling entire plant and each and every data you are acquiring and you are checking and controlling itself. In this diagram, you are going to have the major clarification of entire industrial automation technology. PLC where we use, HMI where we use, and then SCADA where we use. Okay, in this SCADA also we are going to explain about the Inter SCADA and then Siemens SCADA is available. Okay, clear? Next one, last fourth topic is VFD. Variable frequency drive. What is the purpose of VFD? Is nothing but to control the motor controlling purpose. If you want to run your motor, or let's say for example, if you want to control direction of the motor, forward, reverse, if you want to control speed of the motor, fixed and variable also. Okay. Okay. For motor controlling purpose, we have already the previous technology like relay wiring technology is there, like DOL starter, RDOL starter, star starter, both are available. But what is the difference is nothing but motor protection. There is a higher protection is available here. It is going to reducing the starting currents, voltages, fluctuations, over voltage, under voltage, higher temperature. Okay, and it is going to increasing the efficiency of the motor. It is a long term investment to the industry, right? This is the major criteria of the VFD. Okay, up to now, every topic has interlinked with the PLC, right? It is also interlinked with the PLC, but without PLC also it can run. How it is nothing but, let's say for example, one chemical tank is available. Here we have low level and high level sensing is there. Okay, when to run for water pumping, I am going to use one pump motor. To run this pump motor, I am going to use one VFD. Okay, when it is in low level, pump should run. When it reaches to high level, pump should off. Okay, this low level, high level signals, VFD doesn't know anything about this. Okay, let's say if we have manpower, when it is low level, you should check it, and we need to run the VFD. If it is reached high level, you should go on it. It is, you need to off it. That means manual control. Okay, automatic is not available here. It is only the manual controlling it is available. Without PLC also you can run the VFDs and motor controlling also. But what, sir, what is the use of the with VFD, with PLC? With PLC is nothing but, let's say this is low level, high level, everything. PLC is going to take over. PLC is going to give the signal to the VFD. When it should run in the forward, when it should run in the reverse, when it should run in the particular speed or level, whatever the low level, high level, everything. Every signal PLC can take over. As a programmer, you need to write the program of PLC also. We need to write the program of PLC, VFD, otherwise HMI and SCADA. Every program, PLC programmer, you need to think about the programming of PLC, HMI, SCADA and VFD. Depends upon the client requirement, depends upon the industry requirement, depends upon the SOP. Okay. VFD is going to run the motors also. What you are going to learn here is nothing but, if you want automatic, then we should go with PLC. If you are having manual controlling, no need of this one. Okay, how VFD is going to, this is the VFD. Okay, in this VFD, this is the input section, output section, controlling everything is there in the itself only. This is the potentiometer to increase the speed of the motor, everything. Okay, coming to HMI also. This is an HMI screen. Back side of this one, it doesn't have anything, any terminals, nothing. These are the power terminals. These two are the communication related. Okay. In this VFDs also, Delta VFD we are going to teach, Dynamic V20 drive also. Okay. If you want more details about this course and all the things, just contact my number also. This contact details also I can give in the description of the video. Okay. Those who are having need of this type of information and all, share it to your friends and family relation also. Okay, if you are okay for this demo session and all things, give a like and then share. If you are a new member, just subscribe it. Okay, thank you so much.